Hello everyone. Today we shall discuss about the difference between periodic motion and simple harmonic motion. So today we are going to differentiate between the two words, that is what is the difference between periodic motion and simple harmonic motion. So this is what we call it as periodic motion, and let us define the two and find the difference between periodic motion and simple harmonic motion. Suppose periodic motion, we will find the difference between periodic motion and simple harmonic motion. Periodic motion and simple harmonic motion. Harmonic motion. Simple harmonic motion. So we'll find the difference between these two. Number one is periodic motion and number two is simple harmonic motion. And let us find what is the difference between the two. The first most important thing is that the main difference is that the main difference the main difference is that main difference the main difference is that simple harmonic motion simple harmonic motion simple harmonic motion simple harmonic motion, what we call it as SHM, simple harmonic motion SHM is a specific type is a specific type is a specific type of periodic motion periodic motion a specific type of periodic motion where the restoring force where the restoring force where the restoring force is directly proportional directly proportional to displacement to displacement. So where the restoring force is directly proportional to displacement and always points to the equilibrium and always points to the equilibrium points to the equilibrium always points to the equilibrium, while periodic motion is broader, while periodic motion is a broader term. Periodic motion is a broader term. Periodic motion is a broader term for any motion for any motion repeating at fixed intervals repeating at fixed interval repeating at fixed interval. So these are the things we can find the difference between the two. Repeating at fixed intervals, not necessarily not necessarily following following simple harmonic motions, strict force displacement rule, strict strict force displacement rule, force displacement rule. This is the main difference between periodic motion and simple harmonic motion. So we can say that all simple harmonic motions are periodic. All simple harmonic motions are periodic. Are periodic. All simple harmonic motions are periodic. But but not all periodic motions. But not all periodic motions. All periodic motions. Not all periodic motions are simple harmonic motions. Simple harmonic motions. Just like all squares are rectangles. Just like all squares are rectangles. All squares are rectangles. All squares are rectangles. But all rectangles are not squares. But not all rectangles are squares. But not all rectangles are squares. So this is the main difference between periodic motion and simple harmonic motion. So we can say that all simple harmonic motions periodic, but all periodic motions are not simple harmonic. Why? Because simple harmonic motion follows a particular rule between force and displacement. The main difference is that simple harmonic motion is a specific type of periodic motion, but the restoring force is directly proportional to displacement and always points to the equilibrium. While periodic motion is a broader term for any motion repeating at fixed interval, not necessarily following simple harmonic motion strict force displacement rule. All simple harmonic motions are periodic, but not all periodic motions are simple harmonic motions. Just like all squares are rectangles, but not all rectangles are squares. Now we will define the periodic motion and give examples, and after that we will define simple harmonic motion. What is periodic motion? So you can define this periodic motion this way, that periodic motion. What is a periodic motion? First we can define in this way that periodic motions, number one, what is the definition? Number one, we will find the definition of periodic motion. Definition. What is the definition of periodic motion? I already told you that any motion that repeats itself over a fixed interval of time or period. Any motion that repeats itself, repeats itself over a fixed time interval, over a fixed time interval, or you can say it as period, or fixed time interval or period. Number two, force. So this is any motion that repeats itself over a fixed interval or period and can involve any kind of force. Can involve any kind of force. No specific relation to displacement is required. No specific relation, no specific relationship to displacement is required displacement to displacement to displacement is required. So these are the characteristics of periodic motion, and I am going to give you some examples of periodic motions also. Now we are going to give examples of periodic motions. So here you get number 3 as examples of periodic motions. Examples of periodic motion. Examples of periodic motion. Examples of periodic motion. What are these? Examples of periodic motion. So you can say that Earth orbiting the Sun. Earth orbiting the Sun. Earth orbiting the Sun. A planet rotating. A planet rotating. A planet rotating. A clock's pendulum. Earth rotating. These are known as planets rotating around the Sun or the solar system are all periodic motions, right? So examples of periodic motions are the orbiting the Sun or a planet rotating. So these are the examples of periodic motion or Earth rotation. These are all periodic motions. Now we are going to define about simple harmonic motion or SHM. What is the difference? Simple harmonic motion. Simple harmonic motion or SHM. We say it as SHM or simple harmonic motion. First we'll get the definition. What is the definition of this simple harmonic motion? You see, the definition of simple harmonic motion is definition. This is the definition of simple harmonic motion. A specific type of periodic oscillatory motion. A specific type of periodic oscillatory motion where the restoring force is directly proportional. Where the restoring force is directly proportional to the displacement from the mean position and acts towards it, and it is known as Hooke's law. Hooke's law, that is F equal to minus kx. This is the equation of a simple harmonic motion, that F equal to minus kx. Or you can say in this way that force at F is directly proportional to x. That is, restoring force is directly proportional to displacement. Restoring force is directly proportional to that of displacement. You have to remember this one also. Restoring force is directly proportional to displacement. Number 3 is acceleration. About acceleration, what it happens? Acceleration. Acceleration. How will get the acceleration? A is directly proportional to x. A is acceleration. Acceleration is also directly proportional to that of displacement. That of displacement. Displacement. And directed towards equilibrium. And directed towards equilibrium, directed towards the equilibrium. So to remember all these relations, now we're going to give some examples. What are the examples? Examples of simple harmonic motion. Examples of simple harmonic motion. Simple harmonic motion. What are the different examples of simple harmonic motions? We are giving examples. Suppose mass on a spring. Mass on a spring. It is an example of simple harmonic motion. A simple pendulum. A simple pendulum. A simple pendulum. Simple pendulum, but for small angles. For small angles. For small angles. A vibrating string. A vibrating. A vibrating string. All these are examples of simple harmonic motion. A vibrating string. These are all examples of simple harmonic motion. Now we will find key distinction between them. The periodic motion repeats over time, and simple harmonic motion is a special case of periodic motion with a specific linear restoring force, that is mass on a spring. So these are the main difference. In case of periodic motion, so these are the main difference between periodic motion and simple harmonic motion, right? So these are the main difference. What you say? Examples of periodic motion: mass on a spring or a simple pendulum. So suppose this is a simple pendulum, and this is the equilibrium position. B is the equilibrium position. If we take this bob to get this point C or this point A, it will oscillate in this way. And you see here, this suppose this the displacement is x. The restoring force, this restoring force here is directly proportional to that of displacement. And force means what? Ma, mass into acceleration, directly proportional to x. Mass is constant, therefore you can say A is also directly proportional to x. This is the main relations between them. F is directly proportional to x, or you can say F equal to minus kx. Right? So this is ruled by the Hooke's law. So simple harmonic motion means a restoring force is directly proportional to displacement. Or you can say that acceleration is directly proportional to displacement and is directed towards the equilibrium. So the relation is A equal to minus kx. This is also the relation of simple harmonic motion. But in case of periodic motion, there is no relation between force and displacement. So this is the main difference. And we already told you that the simple harmonic motion is a special type of periodic motion, right? Where this force, this acceleration is directly proportional to minus A equal to minus kx, or F equal to minus kx, F equal to minus kx, a rule follows. These two, either F equal to minus kx, restoring force is equal to minus kx, or acceleration equal to minus kx. These two rule follows in the case of simple harmonic motion. But in periodic motion, can involve any kind of force in periodic motion, but no specific relationship to displacement is required. So there is no specific rule for periodic motion. It is a motion that repeats itself after a fixed interval of time. For example, our Earth. Our Earth revolves around the Sun in 365 days, 365 days. So this is for periodic motion, but not simple harmonic motion. Simple harmonic motion can be said to be a pendulum, but it is for applicable for a small angle theta. Or you can mass on a spring. That means suppose this is a spring, it is in equilibrium. And if we pull this spring to certain distance here, extend this spring up to here, then it oscillates along its equilibrium position. Or if we compress this spring about the equilibrium position, it also then executes simple harmonic motion, and it follows the relation f equal to minus kx. F equal to minus kx, or it can be written as a is equal to minus kx. It follows this relation. That is, acceleration is directly proportional to displacement. Or a vibrating string, that means suppose this is a string and this spring will vibrate in this way about the mean position. So these are the examples of simple harmonic motion. So you have to know the main difference between simple harmonic motion and periodic motion. Thank you everybody for watching this video.